Good evening, dear participant. Very good evening. Yeah, in the beginning, you are not able to unmute your mic. I will let you permit. Okay, so here I have the option so that you can unmute your mic during the session. You are allowed to unmute. Okay. Yes. So once again, good evening and welcome back to our ongoing workshop. This is the 13th session of this workshop. Okay. And tomorrow will be the last one. So once again, a very warm welcome to all of you. And I am delighted to have you join us today for this exciting and insightful session on the mainly recommendation model using Python, which is an essential part of modern data science, machine learning, and AI application. Recommendation system are the driving force behind the personalized user experience, whether you are watching your favorite show on Netflix, shopping on Amazon, or listening to music on Spotify. Okay, so today's we will explore the magic behind these intelligent system and learn how to build them using Python and the key libraries. Okay, so whether you are a student, researcher, developer, or enthusiast, this session is designed to give you a solid foundation in how these system work for the basic concept to hands-on implementation. So once again, I will encourage you all to stay curious, ask questions, and make the most of this interactive session. Let's embark on this journey to uncover how machine recommend things smarter than ever before. So let's get started. And I am going to share now my screen. And here is today's presentation. So first, there is overview about the today's session. Then after we will discuss every part one by one. And by using the Python, we will establish one recommendation system. And the most important thing is that in almost all type of the recommendation system or the prediction model which we are establishing are like a similar type of the step we have to follow. Okay, and yesterday also we established one type of the like regression model for recommendation. Okay, for the prediction. So here today we are discussing about how we can establish a recommendation system. Okay, so we will start here with the brief introduction about everything what are required and we will go through. So these are the content which we will cover here in the today's session during the entire session. Okay. So here definition, uses, examples, type of the recommendation system, how they work, key techniques, and importance. Okay. So here we are talking, we are going to start from the very definition of the recommendation models or system. Okay, sometimes we can say the recommendation model, but actually these are the recommendation system. And at the end, when our model is ready, we can deploy. Okay, and the definition, if we talk about the recommendation model, model is a machine learning based system that help users discover items they may be interested in by analyzing data pattern and the user behavior. So on the basis of the user behavior and the data pattern, we can establish a machine known as a recommendation system. Okay, so this is a very simple definition about the recommendation system. And here, what are recommendation system? And what are the applications where these are the helpful. So recommendation system is also known as recommender system. Which are intelligent algorithm designed to suggest relevant item to user based on their preference, behavior, or past interactions. They are widely used in like the platform like Netflix, suggest movies on the TV shows, in Amazon, recommending the product. Okay, Spotify, curating personalized playlist, and on YouTube, recommending the videos to watch next. Okay, so many times when we saw any video on the YouTube, and similar type of the videos will be available along with, and sometimes when we will visit again after switching the YouTube, and you will see that the similar type of the videos are available there. Okay, so according to your interest, if you are seeing any type of the lecture series, so there will be a recommendation, or YouTube will recommend you to see the other lectures which are similar type of the as you have the interest or you are watching any video. Okay, similarly, when uh, anyone we are visiting on the Amazon, or we have purchased any product. Okay, so similar type of the product will be recommended by Amazon. So all these happen since recommendation system is developed and they are using on the platform, so that everything can be easily recommended for the user and according to their interest. Okay, so and also according their history, past history. So when we have the sequence of the product we have purchased from the Amazon, so our history is there, all type of product which we have purchased. Okay, so sometimes Amazon send you email, and many times when we visit again on the Amazon platform, so the based on the history, which type of the product we have purchased, and according to that history, Amazon recommend the similar type of the product. Okay, so all these are the like you can say intelligent system, and we can easily establish all this type of. Okay, but depend upon uh, what type of the recommendation system or the prediction model we need. Okay, so depend upon the problem, and how we can establish this again, very important part which we will discuss here. Okay, users examples you can see here. We discuss all these part: Netflix suggestion, Amazon recommending product, Spotify curating personalized playlist, YouTube recommending videos to watch. Okay, these examples we have discussed already. So what are the types of recommendation system? Okay, so here there are several type, and mainly there will be three type of the recommendation system which we will discuss here. Okay, so these are one type is based on like content based filtering. Okay, and the second one is the collaborative filter, and third one is the hybrid model. Okay, so these are main categories. So in the case of like content-based filtering, recommend items similar to those user like in the past uses item attributes like genre, brand, description. For example, since you like Inception, you might also like be interstellar. Okay, for this example. And in the case of the collaborative filtering, based on the user item interaction, rating, clicks, purchase. Okay, so just like the types, you can see the user filtering, user with the similar test. Okay, item filtering, item liked by the similar user. For example, you can see the people who bought X also bought Y. Okay, so similar type of the product which we have purchased, and we can have the filter. And then next one we have is the hybrid model. Okay, hybrid model is combine both the context-based and collaborative approach. Okay, more accurate and personalized. Okay, this is the one of the type like mix type. Okay, and these are the examples of the you can see here the recommended content-based filtering, and the methodology is based on similar type to those user like in the past and user item attributes you can see here, and these are the collaborative filtering based on user item interaction rating like purchases and types. You can see the user filtering with the similar test. Okay, and here hybrid which is the combination of both above which we discuss combine both content based and as well as collaborative approach. Okay, and this type of the model are more accurate and personalized. Then how these models work? Okay, this is again a very crucial question, how these models will work, or how we can establish. So firstly, analyze the user behavior. Okay, like clicks, watch history, rating. Okay, many times when we visit on the website, or you can see on the YouTube or Amazon platform, just we check by clicking. So whenever we visit on any type of the visitor on any type of the platform, always we share our interest whether we have purchased the product or not, whether we have watched the video or not. Okay, this doesn't matter, but it depend upon which type of the interest we have. Just whenever we will click on any link or any video or any product, we have share our information. Okay, so we have to analyze user behavior and then represent the users items in feature space. Then predict missing preferences or the future action and recommended to top ranked item. Okay, so these are some type of the step which we are required, and you can see here which we have mentioned. So mainly the thing is when we have the information, we have the raw data, we analyze them, the behavior of the user, then we can present according to the history, and we can establish the predictive missing preferences, or we can establish the model, and according to that we can recommend whenever the user will visit for the same platform. Okay, here are the some key techniques. What technique we are using? Okay, so here we have some type of the algorithms and like see here matrix factorization by using SVD or NMF. Then we can have the similarity based model like KNN, which is highly useful for the recommendation. Then we have the deep learning, okay, which is the based on the neural network mainly, okay, and then after reinforcement learning. So actually, we are not talking here types of the machine learning model like reinforcement learning. Okay, uh, there are various type of the learning, but here we are focusing on our model. Okay, so then we have the why they are important. Okay, why these models are important or importance. Okay, so by using these recommendation system, we can improve user engagement. Okay, and we can enhance the customer satisfaction. We can increase the sales and conversions, and we can create a personalized experience in apps or the website. Okay, so these are the applications, and we are not required to suggest or anything, but all these things when we have the recommendation model, by using the same, we can this will do automatically everything. As you can see the example of like Amazon or YouTube, Facebook also is there. So all type of the like social media have their intelligent model. Okay, so according to the test or the interest, they recommend their product. Okay, so now this is the brief overview about the recommending model. But the most important thing is how we can establish. So there are some sequence of the steps which we need to follow, and each step by step, and what we need. The most important thing is the data. Okay, so by using the data set, we can establish any kind of the recommending model. But here in this today's session, what we are doing, we will establish a model for crop recommendation. Okay, so you can see this is my yes. So this is the entire code, and here uh, we have some data set. Actually, without data, we can't do nothing. Data is everything, and on the basis of the data, okay, we can develop any kind of intelligent or the recommending tool, and we can train for any kind of the problem, whether it is related to the health science, whether it is related to the agriculture, whether it is related to the any kind of a business, any pol science, okay, political problems or the issues, okay, environment problems, and all type of the as you know, AI working everywhere, and on the basis of the data, whatever we have, on the basis of the data set, we can easily establish this type of the model. So here I want to present one example, and I have a crop data set. So first I want to show you which type of the data I have. Okay, and then by using the same, we will develop the model. So inside here, I have crop recommendation. So see, I want to open this file. Yeah, try again. Not working. Or if I open this file. Okay. Yes. So here you can see this is the file. And in this file, you can see first check this. Okay. So here on the top, you can see we have some parameters. NPK,
Hello, sir.
nitrogen, potassium, okay, temperature, K is also one type of the calcium,
Hello.
humidity, pH, rainfall, and at the end we have label. Yes,
Could
you can
you
unmute your
next
mic.
here?
Yes, please
Sir,
share your
still have
PowerPoint.
the screen for the power.
Just 1 minute, I have to connect my 1 minute, please.
Kindly check the chat box. The chat box.
1 minute, I have to connect my mic. Just 1 minute. 1 minute, please. I forget to connect speaker with my system. Okay. Yes. Yes, you can unmute your mic now.
Yes, sir. Your screen was showing the PPT slide.
Okay, okay, okay. Thank you. Thank you. Thank you. Okay.
Welcome.
Yes, you are right. I did not share the other content. Yes. Okay, so now you can see uh, this is the CSV file. Okay. So here in this file, what you can observe, we have several parameters: N, P, K, nitrogen, potassium, calcium, temperature, humidity, pH value for soil, rainfall, and at the end we have the labor. Okay, since this is the model for the crop recommendation. So according to these parameters, we are going to establish one recommending system. Okay, and in the last column, these are the labels. Okay, so according to these parametric values, when these values will match according to our input, then this will predict the crop. Okay, since for the different crop, different rainfall, pH value, humidity, temperature, nitrogen, potassium, different type of the levels are required. Okay, so just like you can see here in the last column, we have the rice, and then you can have maize is there. Okay, then you can say uh, chickpea is there. Okay, so these are about 20 crops are there. Okay, and corresponding to each crop, we have 30, 100 sample. Okay, these are the samples which you can see. Okay, this is one sample for this crop. This is the second sample, third sample, fourth sample. So for each crop, we have 100 sample, and there are about 22 crops. Different names are there. Okay, so this is the CSV file where actually these are the numerical value, and according to this level, we have the crop, and if we will follow this recommending system, then we can optimize the production of the crop. Okay, so here I'm not showing all the thing, all the crops, because yes, there are many heavy data. So there are, you can see about 2200 rows are there. Okay, it means there are 22 crop. Okay, so this is the actual our data set, and on the basis of this data set, we will develop our recommending system. Okay, which will be very quite simple. But the thing is, the previous lectures and many things we have discussed, and yesterday we established one prediction model. Okay, so many steps will be similar, and by doing so, we can easily establish. Okay, so here, without losing any time, here you can see I have two files. Okay, one is this one, and other is this one. Okay, so I will talk about this one. Okay, so here, just 1 minute. Yes, fine. So here, what we need first, two libraries, and all of you are very familiar about these two libraries: import numpy, import pandas as PD, and numpy as PD, NP. So these two libraries initially we are required, and then after we are reading the dataset which is inside the CSV file, and the file name is crop underscore recommendation. Okay, with this name we have the CSV file, and from the CSV file we will read this data set, and we store inside crop. Okay, so first I will execute this cell, and then I will execute this cell, and when I will execute crop.head, so this will return top 5 rows along with their parameters, their you can say the variable name. So here we have the variables N, P, K, temperature, humidity, pH, rainfall, level. So these are the first 5 rows. Okay, and their values are there. These are the index 0, 1, 2, 3, 4. Okay, so by using this statement, we can have only the top 5 rows with their header name. So this type of the data is inside our CSV file, and I have shown you already. So now, and these are the label. Actually, these labels completely depend upon the other parameters. And on the other parameter, we are going to establish a model. Okay, so you can say this is the output value. Labels are just like a output value, or the others are the input values. Okay, so when we will give this type of the input in our data set, and that data set will match, and then this will predict the value. Okay, so in this way we are going to train our model. Now, then after, and these are the same step which we do for check which type of the data is there, size is there, okay, cleaning, etc. So we can get the info, we can establish the correlation matrix, we can check the heat map. So all these steps will be similar, and we are also using in this file. So when you will use crop.shape, this will return the size of the data set, and you can see here there are 8 parameters and 2200 rows are there, 8 column and 2200 rows are there. And after you want to check the info by using crop.info, and when you will enter, okay, so this will return the info. And by using this one, you can see in the first column there are only we have the index, and the second column we have the parameters which are inside in our data set. Okay, so here you can see N, P, K, temperature, humidity, pH, rainfall, and at the end we have the label. Okay, so NPK, these are, you can see, integers, and no null shell is there, and counting of each variable you can see 2200. Okay, so you can see 2200, it means there is no empty shell. Okay, temperature, humidity, pH, and rainfall, these are the float values, and NPK, these are integers. Okay, so then after we have the last label. Label is object. Okay, so since all these in the last column label, we have only the name of the crops. Okay, and if you want to check here, crop dot is null dot sum. So this statement will check whether there is any empty cell or null cell. This will return the counting of the empty cell. And when you will execute, actually all the statement before starting the session, I check and executed. So that's why values are there. And when you will execute, you can see that the values of N, P, K, temperature, humidity, pH, rainfall, level, all these are 0. The meaning is that there is no null shell. Okay. Then after, yes, then after we can have duplicate, we can check the duplicate value. Okay, and there is no duplicate value. Okay, and here we are using crop dot. Actually, crop is our main variable where all the data set is stored inside crop. Okay, so from crop we want to check the duplicate dot sum. Okay, first this will detect the duplicate value, then sum is used to count the values. Okay, so when you will execute this statement, and you can see 0 is there. It means there is no duplicate value inside our dataset. So all these are the mandatory step before implementing any kind of the intelligent algorithm. Okay, we have to check our dataset, and these steps which we are using here, we discussed in the previous sessions, and without doing all these steps, we are not able to establish our model, since we have to prepare our dataset in the very beginning level. Okay. Then after, many times we have used this statement also, crop describe function. Okay, crop dot describe. And as you know, this will turn the descriptive statics about our data set. Okay, so here you can see on the top we have the variables N, P, K, temperature, humidity, pH, rainfall, and this will return the values corresponding to numerical values. And you can see that object is not there. Okay, and you can see in the first row we have the count, and each have the same value 2200. Then we have the mean, STD, minimum value, first quartile, second quartile, third quartile, and maximum value. Okay, for with respect to each parameter which are inside our data set. Okay, so this will also again help you to study our data set, and what are the impacts sometimes if we don't have any variable which are inside our data set. If sometimes we have very variables are very large, we can remove unnecessary variables. Okay, then after you can see here, drop the non-numerical column. Okay, now actually when we want to establish the correlation model, correlation between the variables, in that case, correlation is established only between the numerical values. And inside our data set, there is one column with the name label, and inside label, there are only the name of the crops. Okay, so for the correlation matrix, we have to drop this label by using crop dot drop label axis 1, and after that we are using correlation function. Okay, dot corr. So this will establish the correlation between the all the variables, okay, except label. Okay, and here display the correlation matrix. So when you will execute this shell, shift and enter, shift and enter. So here you can see this is the correlation matrix. So on the top you can have N, P, K, temperature, humidity, pH, and last column rainfall here. Okay, and also in the first column we have the name of the parameters, okay, which are on the column. So the same we can see here at this place: N, P, K, temperature, humidity, pH, rainfall. So as we discussed in the last lecture, when you will find the correlation with itself any variable, that will be always equal to 1. So here you can see N with N will be 1, P with P is also, we can see here this value is 1. Okay, and when you will take K with K, that is also again 1. So the column of this matrix are equal to 1. Okay, so here when you will check the P with N, we have the value minus 0.231460. The meaning is that we have negative correlation. Okay, and here you can see the value is 0.736232, highly correlated with K. Okay, and so on. We can check all the values, and according to these values we can check which variable have the positive correlation, which variable have negative correlation. Okay, and which are highly correlated, which are less correlated. So from this entire table we can easily study the entire data and the relationship between them. Also, we can use the heat map. Okay, and for the heat map, we have to import Seaborn as SNS and matplotlib pyplot as PLT, as we discussed in the previous lecture. And the same steps are there. We are not doing nothing new one. Everything are same. Okay. So here, when you will use this statement, and this will return the heat map, as you can see here. This is the heat map. Okay, so the values in the heat map, you can see the minimum is minus 0.2 and the maximum value you can see inside at the place we have is 1. Okay, since all the diagonal element you can see inside we have is 1. Okay, and minus 1, no value. So the minimum value we have is minus 0.2. So here from this matrix, you can see easily compare the values, and as much we have the dark color and light color, all these are reflecting the correlation, whether this is a positive or negative. And for the highly negative, you can see this blue color. Okay, just like you can see here, minus 0.17, minus 0.12, minus 0.16, minus 0.13. All these are the negative correlations. Okay, and when you will check light blue, here you can see just like this variable, which is 0.094, which is very close to 0, and the relation between humidity and in this side we have is rainfall. So rainfall and humidity are correlated but very less. Okay, similarly you can check the pH value, pH and rainfall, that is minus 0.11. Okay, so from this entire heat map we can easily study the entire uh, correlation among all the variables. Okay, so this also again help us to study our data set. After that, you can see crop dot label dot value underscore count. So this will return the counting of each label. Okay. So when you will execute shift and enter, you can see that we have the counting of each label. And as I told you in the beginning, we have 100 sample with respect to each crop. Okay. So rice, with respect to rice, we have 100 sample. Similarly, we have the maize, jute, cotton, coconut, papaya, orange, apple. Okay, and all these are the crop name. Different crop names are there, and their respective counting is there. And you will see that each crop we have 100 sample. Okay, as once again you can see in this side in this file. Okay, you can see coffee. Okay, so this is one sample. This is one sample for coffee, and you can see all these values different. This type of the range is variation is there. Rainfall is different. pH value is different. NPK values are different. Okay, so when this type of the random values will we have, according to that we can recommend the crop. Okay, and this will help you. And come back here. Okay, so these are each 100 sample with respect to each crop. But one more thing I will let you know is much 100 is not sufficient. For more accuracy, we need some more data set. So as much we have the large data set, we have more accurate prediction. Okay, I'm not showing sure saying that the model which we will establish will be more perfect. But if we increase the data set, we can have more accurate results. But still, the model which we will establish, and whenever these values will, according to the values which we will give the input values, according to that, this will return the output value. Okay, the model will recommend the crop name. Okay, so here also you can see the unique values. How many unique values are there? So there are 22 unique values. These are the label name. Okay. So 22 crops are there. So on the basis of these 22 crop, we establish a model which will recommend the crop. Okay. So now here come to add this place. Import seaborn as SNS and import matplotlib.pyprot as PLT. We are having the just like histplot, okay, for crop and x is equal to p KDE true. So KDE will we have the curve along with the histogram, and many times when we will in the previous sessions, uh, and also you can fit the normal distribution, binomial distribution, etc. also can be used for the same. And here distribution of the phosphorus we are taking here p is phosphorus. Okay, so shift and enter. Yes, so here this is the map corresponding to phosphorus. Okay, so at the horizontal line you can see p is used for phosphorus. Okay, and uh, this is the count on the vertical line. Okay, and you can also observe the how the data is spread over the given range. We can easily observe from this side. Okay, similarly we can check for you can say the nitrogen. Okay, here we are taking the variable nitrogen, and we can use for all type of the parameters which we have chosen here. So this is the distribution of the nitrogen. If you need to check how the data is spread for each variable. Okay, so you can change for the other parameters also by doing in this way. Here we have the unique labels. This will help us. Okay, crop dot label dot unique, and whenever you will execute these are the names: rice, maize, chickpea, okay, kidney beans, and so on. So all these are the crop name, and in the array format. Okay, we are using these names here. You can see crop dictionary. We are storing. Actually, the thing is that when we have to convert these values, these name of the crop, since we need numerical values. Okay, if we want to establish the model, we need only the numerical value on and only on the basis of this crop name. We are not able to establish. That's why with the help of crop dictionary, we can convert in numerical values. So far, you can see rice is the key and the value is 1, maize value is 2, jute value is 3, and so on. Scroll down and you can see these are the last one is coffee. Okay, so in this way we can convert all these object values into the numerical value, and it is required. Without converting in numerical value, we are not able to establish the model, since the model will study only the numerical value. Okay, so it is important part. So now this part also required to execute shift and enter. Yeah. Then after the values has been stored is numerical value, and now once again when you will check crop dot head, it is required whether all these are changed or not. So when you will use your crop dot head, and you can see now in this data set we have all the values are numerical values. Okay, NPK, temperature, humidity, pH, rainfall, and you can see the last level. One is used for rice. Okay, two for the next crop. Okay, you can see now according to the names which we assign the values, 1 for rice, 2 for maize, and so on, the entire label has been converted into the numerical values, and we can see in the this data set, okay, by using the head function. Now when you will check here the unique values, okay, so in the place of names of the crop, here we have the only these names which you can see numerical values. So all the names replaced into numerical value. And previously there was the name of the crop, you can see here. See this data set. Okay. When you will use the crop.label.unique, we have these values, which are the name of the crops. But here we have the numerical values. Okay. And yes, you can see all these are the numerical values. Means that all the object has been converted into numerical values. And now if you need to check the count of each of these numerical values, and you can repeat the same step. You can see here these are each 100. So these are the labels. Previously at this place in the first column label, we have the name of the crop, but in the place of name of the crop we have numerical values, and corresponding to each numerical value the size is 100. Okay, so it means the operations which we apply according to our need are accurate. Okay, and then after, yes, so the thing is to establish the model, we required two variables. Okay, one is the input and second is the output. So here we are splitting our dataset into two variables. One is x. Okay. So what we are doing here, we are using x is equal to crop dot drop, and for the drop we are dropping the last label. Okay, and here the label is stored here inside y. Okay, so y is the value or the label which we need to predict, and all the values which are inside x, these are the input values. Okay, so in this way what we want to recommend or what we want to predict, okay, y will be the uh, predicted value or the required value on the basis of x, which are the input values. Okay, so in this way we have to split our data set, and then you can shift and enter, and here we can check the data set. Okay, so now x heads are, we have n, p, k, temperature, humidity, pH, rainfall. So here label is missing. Okay, so these are the x head only. These are the x head. Okay, and inside x head label not required, we have dropped the label by using this statement. Okay, and then after these are the y head is. Okay, if you want to check the y head, and in the y head only we have one column. Okay, so these are the y head only. Then after, the most important thing is now we are going to establish our intelligent model. Okay, and here the statement inputs you can see are the same as we do yesterday. Same steps will be here, but some more elaboration we have included at this place so that this can be more useful and understandable for you. Okay, so these are the library which are the required to train and test and separate the model. Okay, so here you can see we have x train, and y train. X test, y test. Then train underscore test split. Here is the xy test size. Okay, test size we are using 0.2. Okay, 0.2 means 20% is used for test and other 80% for train. Okay, so this is the ratio. So the test size we are taking here 20%. 0.2 means 20%. Okay, and we need to execute. Shift and enter will be executed. Okay, shift and enter. Now if you needed to check the X train shape, okay, how many rows and columns are there inside X train? Okay, so you will use only X train dot shape, and this will return. You can see the size 1760. These are taken for training the model. Okay, so and for the test we have only is 20%. Okay, and 80% for train the model. Okay, so these are the values for the train, and if you want to check for the test, you can use at place test. Okay, so this will return the size of the test, and as well as you can see as the size of training the model. Okay, so one part is has been completed or accomplished. Now come to here. We have to import one more library from Scikit-learn pre-processing import min-max scalar. Okay, and here mx is equal to min-max scalar x underscore train mx dot fit transform x train and x test mx dot transform x test. This is the required. Okay, and when you will execute, and then this will transform. Okay, and here we can check the value. Here we can check the values. So this is the yes. So here we can check the train values at this place. Okay, if it is required or need to study. Then after we have to use here standard scalar. Okay, and we are taking here for okay, this is the same step. This is the same step as we do above. Okay, and then after we are using here, these are the models. And now this is the level where we need to apply the model, and we are using here several models, just like logistic regression is there, Gaussian NB is there, SVC is there, K neighbors classifier, then decision tree classifier, extra tree classifier. We can use random forest classifier, bagging classifier, gradient boosting classifier, and you have accuracy score. Okay, and ADA-boost classifiers. So all these are the machine learning models, but here we use multiple, and when we will execute all these model, okay, first we are importing all these machine learning models, and then we will implement all these model. Then we will check which model return the more accurate value. So according to that, we will check which model will more suitable, and we will apply that model to train our machine or to develop intelligent model. Okay. So what you will do first here, we are executing this shell, and here we are importing all type of the models, which you can see observe here. There are so many classifiers and models on the different type of okay. So this is the linear model, nav based model, highly useful. SVC you can see here, neighbors tree. Okay, so these are the models which we can use for the machine learning. Okay, now here you can see how we can implement these models. So here the way where we will apply the models, and we will check the values which will return the more accurate. Okay, so according to the prediction value or accuracy, according to that we will choose the model. So here first we are going to implement here logistic regression, and this is the function name. So this is the name which you will use for the model logistic regression. Okay, this is the model name Gaussian NB, and this is the function. Okay, similarly we have the other type of the models you can see here. And now when you will execute shift and enter. So okay, so all these models has been executed. Now then after here we for name model in models dot item model dot fit x train y train y prediction is equal to model dot predict x test, then score accuracy. So this will return the accuracy of the above models which we implement at this place. Accuracy underscore score y test y predict for those. Okay, and then we will print their score values. Okay, so when you will execute shift and enter, yes. So here you can see these are the accuracy, the numerical values which you can see on the right hand side. Okay, these are the accuracy level. So when you will use logistic regression model with accuracy we have is 0.96, the meaning is that 96%. Okay, if you are using Gaussian NB model with accuracy for this data set, okay, these are the values for the data set we are using. Okay, and for this machine learning model, so we have the accuracy at place we have is 0.9954. Okay, the meaning is that 99.54%. The meaning is that 99.54%. Similarly, you can see here SVC model with accuracy 0.96. This is the 96.81%. Okay, here we have is 95%. Here we have 98%. Here we have 90%. That is 99.3%. Okay, this is also we have 98%. So we use all these model, and according to this model we have the accuracy rate is there. So when you will observe all these models, and you can use either this model, this is the high accurate, you can see it is 99.54, and there is one more, you can see one more model is there. Okay, this one 99.31. Okay, either you can use a random forest classifier, or we can use a Gaussian NP model with accuracy. Okay, so here you can see now one of them, these two are the highly accurate models. Okay, so here we try to apply the shared model. Okay, and we can see the result. So according to this data set, we can easily study the accuracy rate, and according to that we can choose the model and we can apply to develop our you can say recommending system. Okay, so here you can see, come here, we are using Gaussian NB. So this is the actual our model. You can see random CLP is equal to Gaussian NB, and rand CLP dot fit we have x train y train, y predict is equal to rand CLP dot predict x text, and accuracy score we have is, and when you will use this one we have is 0.9954. Okay, so this model we can use to establish our you can say recommending system. Okay, so all these steps are required, and you can see how we can check the accuracy. So if there is any doubt related to this part, you can ask me. Otherwise, I will show you how you can write your function. Then you will give the values, and this will return the predicted value or the recommending value. Okay. So if you have any question, you can unmute your mic.
Good evening, sir. How are you?
Yeah, good evening. I am very fine. And you?
Uh, I just want to ask if the set of data change, the accuracy will change. So we have to see that which one is more suitable every time the data change, or maybe we take more data like 1,000 sample instead of 100. We have to check the accuracy every time.
See, we are using here several models you can see. Okay. So here, when we study this entire accuracy rate based on this model, okay, and we see that we observe that this is the highly accurate. This is the highly accuracy value. Okay, so this model is more suitable. This model is more suitable uh, for this prediction. Others also can we can use. Okay, so this model and uh, one is there. Yeah, this one. You can use also this model, random forest classifier. Okay, so this will return 99.31% accuracy. But the previous one, which you can see here, this will return about 99.54. Okay, so this is the this model return highest accuracy among all the models which we are using at space. So we can use this model. So if we will use this model, the accuracy for this dataset is 90, more than 99%, which is 99.54 and so on. If you are using this one, this model, one is there, 99. Okay, this model, random forest classifier. Okay, that is also have 99 or more than 99%. Okay, but less than Gaussian NB model. So if you are using Gaussian model, the address space, if you want to change, you have to change the name only, address space. Okay, if you are using Gaussian NB, then we have this accuracy. If you will change the name of just like if you are using, we are using this model, you will copy the name of the model. Okay, and just you can use at this place, paste here, then execute. See, okay, this is the extra tree classifier. Okay, we are using here extra tree, this one. I copied this model. Okay, so according to model, the values will change, and this will return the accuracy. So our accuracy, high accuracy, we have by using this model, Gaussian NB. So once you have decided the model, we can go for the next level. See, you got it? Is it clear for you?
Yes, sir. Thank you. Yes,
Okay.
yes, it's clear. Thank you so much.
Okay. Thank you.
Good evening. I have a question.
Just 1 minute.
Okay.
Yes, you can ask now.
Okay. My question is in a situation whereby just like yesterday, that when you are doing the what's called the prediction, the value that was given was after everything, the prediction was very low. In that particular situation, if you want to fine tune it to ensure that you have a very high correlation, or let me say high prediction value, How are you going to go about it? And then I used to hear something again, my question number 2. I used to hear something again about the hyperparameters. How can we be able to make sure that this what's got the parameters that we are going to make use of is going to be suitable for us to be able to have a very high value of prediction? So those are my 2 questions. Thank you.
Lukman, actually, your question is very long, and I don't get the exact question. What you want to ask?
Okay, let me make it very short. In a situation whereby we make use of these predictions, these are machine learning prediction stuff, and the value is not giving us what we desired. Maybe we are desiring like 0.95, we are desiring 0.90 to maybe 0.99, but the prediction that it was giving us, it was giving us like maybe 0.60, and we want to make sure that we have this 0.99. How can we go about that in order to be able to achieve that? That's question 1. Now, question 2. Okay. Continue.
I'm sharing my screen.
Okay.
See here, you can see actually when we have any kind of the data set, and if we are using any kind of the data set to develop, just like we have the crop data here, okay, and we are using this crop data for crop recommendation on the basis of the parametric values. So the same if we have the data set related to any like of disease, okay, the data set which is related to for health. So for the data set, if we want to check or we want to prepare a model for disease prediction, if this type of the parameters will change, then this type of the disease will be there. Okay, so the one thing is their label. Label is very, very important. As I saw you at space. See, in the last column, you can see the labels. Okay, so these labels are based on these some parameter values. Okay, if this type of the parameters will be there. Okay, so according to these parametric values, we have this type of the crop. Similarly, if there is any kind of the disease, then disease also depend upon several type of the parameters which are related to the health science. Okay, so I will try to present one model for related to the health science. So this will be more supportive. So any disease, when we check whether it is a to prepare our model for any kind of a disease, we need which parameters are involved there for this type of the particular disease. And one of the best of these parameters, and the disease name is the label. Okay, say malaria, typhoid. Okay, when we have several diseases, the different parameters are there, and according to different these values, temperature level, body pressure, or other parameters which are involved for the disease. Okay, so we need to put the numerical value. Okay, so according to these numerical values, we have some label. So as you can see here, these are only the numerical value, and the crop which we are choosing here depend upon the 7 parameters, and all the parametric values you can observe in this data set. All these are different. Okay, so on the basis of these values, we have the respective label or the value, which is the crop name. Okay, now when we are going to establish the model, okay, we have to first level is to prepare the data. And when you come to add space to apply the machine learning model. Okay, here various type of the models we can have for the prediction, for the recommendation, which some are the machine learning models, some are the related to the deep learning models are there. So there are so many models are there, and for the prediction or the recommendation, we can use this type of the models. You can see here. Okay, and we have to check which model will return more accurate value. Since the when we have the model, so we believe in the accuracy. How much accurate is our model? Okay, how much is intelligent our model? Okay, if we have the less accuracy, then why the people will take the less accurate model when we have the other model which is more accurate? Okay, so according to we need to check the accuracy, and it is the very important part. So as much we have close to 100%. Okay, and here when we are using these models, and you can see that corresponding to this model, we have different accuracy. But the high accuracy is by using this model, Gaussian NB, okay, which is 0.9954. The meaning is that the accuracy at space is more than 99%, okay, which is about 99.54%. Okay, similarly, all these are the percentage, okay, but the value at space is starting from 0 point something. But first two digits are the percentage. Okay, so and again, if you will see this model, one is there. This model is returning 99%. Okay, and here is also one more model. You can see this one. This is also returning the 99.31%. Okay, so which model is returning the more accurate value? We have the Gaussian NB. So we can choose also the random forest. Actually, there is a very little difference between these two. Okay, both are more accurate, high accuracy. Okay, more than 99%, and more than 99% is good model. And here we can choose one of them. And also how you can use, here is the respective values. Okay, when you will use here Gaussian NB, and you can see that the value is 0.9954 something. So we can use this model, and we can establish the intelligent model which will recommend the crop on the basis of the input values. Okay, so now I think I tried to justify your question. Is it clear? Is it clear? You got it? Still there is any question?
Yes, there are. So from your explanation, what I got from your explanation now is that there is no way in which you are going to have a data set if you should run it using all this model. There is always way, as in from out of all this model, there is certainty that 1 or 2 or 3 is going to be reaching 0.99%. Is there a situation whereby even after running all this model, you still
Actually, without doing the experiment, without checking the accuracy, okay, the accuracy we need
to this 0.995?
0.955. Okay, you can use this one, but this will return the less accuracy. Okay, if there are some other models are there, and we can check the more accurate model, we can by using all these model. If we have more accuracy, then why we are using 95%? If we can establish more accurate, like 99%, then we must use that particular model. Actually, all the different models have different accuracy. Okay, depend upon the model type, parameters. Okay, the number of the parameters, how many parameters are there. So according to those parameters data set, the variation will be there. So on the base of our data set, we have to check which model return more accurate value. Okay, so for that we will use or we check the a highly accurate model, and that we will use to establish our recommending machine. But without doing experiment, without checking, but actually when we check the accuracy, we have to apply different models, and then we can come to the conclusion which model can we have the more accurate recommendation.
Okay. Okay. That's okay by me. The second question is in this, I used to see some of data sets in which they are going to split the data into the training set, the validation set, and then the test set. But
Can you please repeat your question? I don't get it. Can you repeat your question? Okay, first let me complete this one. If you have some more questions, we can discuss offline by sharing your questions or the other way. Okay, so first I need to complete this model.
okay.
Yeah. Sorry. Uh, Here, see here, add a space and okay. Just 1 minute. Yes. Okay, here we can have just 1 minute. Yeah, here we are using random forest classifier. Okay, random forest classifier, and you can see here the accuracy is more than 99%, or you can use the above one, this Gaussian and Gaussian B model. Okay, Gaussian NV model. So either you can choose this one or you can use random forest classifier. Both have more than 99% accuracy. So here the dataset is the same. In this file, the dataset is same and same steps are there. Okay, so this is the final stage. So when you will train by using random forest classifier, then at this place we are evaluate the model. Okay, so when you will shift and enter. Okay, so here you can see we have the accuracy rate. You can see here, which is 0.9931. Okay, 0.99 means 99.31% approximately. And this is the classifier report. You can see F1 score is there, spot is there, recall, precision, etc. about all the parameters. Okay, and you can see the accuracy micro average 0.99 for each. Okay, and weighted average also 0.99, 0.99, 0.99. Okay, so when we have this is the report for each variables which are inside our data set. Then after we can write this is the last stage of the model. We have to write here crop prediction function, where you can give some. Our model is ready now to use. Now we are writing the function where you can give the input, and on the basis of your input, this will return the value. Okay, on the basis of the parametric values which are enrolled inside our model. Okay, and here you can see we will start the function in Python is definition def. Then we will put the name of the function. Function we have is predict underscore crop, and here we will give the input data. Okay, and the data set will be predict crop based input feature. We have the data set in the form of a list. You can see in this form we need the data. So the parameters which are involved is we have N, P, K, temperature, humidity, pH, rainfall. So these are the parameters, and the values of these parameters are required. Okay, then we have the input dot df pd dot data frame input values. Okay, column X, and the value which we will give the input, and this will predict the, then our model will predict the value. Model dot predict input df. So whatever we will give the input, according to that this will return the value. Okay, this is the, you can see return le inverse underscore transform. Okay, this will predict the value. So this function is required to write, and then after, by using this function, and we will give the input, and this will return the requirement according to the values. So here we have the example. Here we have the example for the prediction, okay, or the recommendation. So this is the sample data. This is the sample input. Okay, and this sample input we are using to check which crop will be there. So these are the different inputs from our side. These are the input from user side. Okay, corresponding to these parameters which are here. These are 7 parameter, NPK 3, then temperature, humidity, pH, rainfall. These are 7 parameter, and NPK are integer. So these are the integer value, 16, 80, 20. Then after we are using here values for the temperature, then humidity, then pH value, then rainfall level. Okay, and all these are float values. Okay, so these are the input from the user, and these values will store inside sample data. Then we are using at this place function which we write in the above, predict underscore crop. Predict, we write here function, this one. Okay, predict underscore crop. So we will give the input. Okay, and these are the input values. Okay, we need to pass through this function, and here we are call the function predict underscore crop and sample data. These are the input values which are stored at its place. Then the output will store inside predict underscore crop. Okay, and then we will print the value. So when you will execute shift and enter, so according to these parameter, okay, these are the values which are given or chosen by the user. Okay, and according to these values, the predicted crop or recommended crop we have is this one, peasant peas. Okay, this is the crop name. According to these parameters, rainfall level, okay, humidity level, pH level, then nitrogen, phosphorus, potassium. Okay, so according to these parametric values, this suggests that, model suggests that the crop must be their peasant peas. If we will use this crop, or we will have this crop in our land, this will have the more production according to the environment conditions. Okay, so these are the environment conditions which we give the input at a space, and this is the trend model. Okay, so just you need to put your values at this place, and according to the values you will have return the crop name. Okay, So now the next level is you can deploy this model. Okay, for that you need engineer help who are software developer. Okay, they will prepare front end and back end. This is the part of the back end of the system. Okay, and when the model is ready, then on the front end, just like we have the website, on the website, there will be only the input values. There will be 7 column where you will put the values for nitrogen, N, P, K, temperature level, humidity, pH, rainfall. So when user will put these values inside there, this will automatically, when you will press enter, will recommend the crop name. So according to the environment conditions, we have to you can say in the field you will crop you will saw the this type of the you can say the crop. Okay, so in this way you can see this is the overview about the model and how we can train, how we can predict, how we can write our function, how you can put the values. Okay, so when you will deploy, only this part will be there. Only you need to give these values. Okay, nothing. So the model will automatically return the crop name according to the input by users. So this is all about the model which I want to present here, and I hope that you got some idea and some idea, multiple ideas you can have. You can, in this way, you can train your model for health science, for environment conditions. You can have any political uh, predictions or the recommendations. Okay, you can prepare for the business intelligence model by using in this way, but depend upon your data set. Data set is very, very important. Okay, as much as you have large data set, you can easily develop your model. Okay, so I hope you have some idea. You can now able to understand and you can prepare your own model for the recommendation and the prediction. Okay, this is all about from my side in the today's session. So there are some participants who are attending this session through live stream, and many participants are regularly attending our session. And thank you to all the participants, those who are attending through live stream on the YouTube. Okay, and these participants are from different places also. Okay, but I don't know their names, etc. But 2 or 3 participants are regular attending these sessions. So thank you to all to attend this my entire session. Okay, now if there is any question or any discussion from your side, session is open for discussion. Yes, please. Any question, please?
Yes, sir. How are you?
Yes, I am.
I want to ask if
Ma'am, your voice is breaking today. Your mic is not stable.
that that's mean we are developing the
Suhair, actually, your voice is breaking. Uh, your mic is not stable. Yes, Mustafa, Grema, thank you for your question. Yes, actually, as I told you that data is very, very important. And whenever you have the data and labels, we can establish any kind of the model, whether you are working in health science, environment problems, okay, or in business data, or any like product recommendation you can do. Okay, you can prepare model for the just like career recommendation. Okay, so everything is possible, but what you need, this is the one example. Okay, what type of the data you need, how you can prepare, how you can make the intelligent, what type of the algorithms are there, which type of the model we can do. So everything I try to present in this one by using one model. Actually, we need some more concept about machine learning, deep learning, types of machine learning, types of deep learning, and which actually we can have the data set like images, we can have the text, we can have voice. Okay, so various types of the data is available, and sometimes we can have only the like just like object type or the string type data. So from the string type of data, we can also extract some information, we can train the model. But the thing is again, if we have the dataset like object or strings are there, we need to convert all this type of data into numerical value, and then only then we can develop intelligent technique. Okay, if we have the just like images are there, okay, for different type of the conditions, levels, okay, and these images can be related to the crop to study the disease of the crop. We can have the just like X-rays. Okay, X-rays are the one type of the example. Okay, X-rays of any part of the body. We can have the images of the retina. Okay, so several samples we need to collect, and when we have the large data set, we have more accurate. So accuracy always will depend upon size of the data set. So as much we have the large data set and as much we have large number of the variables, parameters, we have more accurate model. Okay, but to complete this entire models, how we can establish our model accuracy, etc., we need some more sound background. We have to study some more content about the just like artificial neural network is very important. Mathematics is also there. Okay, computing part is the other part. I don't think that computing is more typical. Computing is simple, but statics, mathematics, and their computing part as well as data set, artificial neural network, ANN, CNN. Okay, all these are very, very, very important. So just in the flow of our workshop, I consider that some simple model, if we can present, you will be able to understand how the machine learning models are developing and how we can develop our model. And I think that the model which I try to present for you have some idea according to your domain. Okay, and you can also establish this type of the model for the prediction, for the recommendation, okay, for the dynamic model to control anything by using these ANN or CNN by using the different type of the algorithms are also there. So every part is required to understand, to study, to implement, experiment. Many things are there. Okay, so only by presenting one lecture on recommendation model, okay, not sufficient. Many skills are required. Then you will be able to uh, understand everything. I know there will be some doubts will be there. Okay, but you have to start. You have to understand everything. Actually, the theoretical part for this machine learning model, we skip everything. Okay, so theory is also what behind the logic, which type of the model. Actually, if you will go through about the ANN and CNN and types of the machine learning and their modules, this will make more understanding about this type of the models which we are talking about to establish for recommendation, for the prediction, and many more. Okay, so if you have any more question, please feel free. I try to justify.
Okay, sir. I have one question. During your course of presentation, you said the number of data must be large enough. So what is the barest minimum of large enough? Because 1 million data set is still large. 100,000.
Actually, the thing is when the data set we have for one parameter about 10,000 or more than 10,000. Okay, so sometimes we have 50,000. You can see weather prediction. You can see the weather prediction. Okay, so when you will check what about the temperature weather in the coming week, and according to when you will check the recommendation, the same thing will happen within coming days. Okay, so since the data set of the environment which is collected, and in the beginning when prediction was started about the weather was not more accurate, but now you can see that the prediction of the weather is more accurate since the data set stored in very large. Okay, and similarly you can see the in the case of ChatGPT in the beginning this was not the more accurate, but now actually the data set is very large, so that's why it is returning the more accurate informations. Okay, so when we will in the beginning start to establish any model, so more information will store, and by using CNN deep learning models, the machine automatically learn from the inputs. Okay, and also we all are making these ChatGPT or other generative AI tools more intelligent by giving our input by our suggestions. Okay, so as much we have the large data, we have more accurate. But here we are training on the basis of the data set what we have. So if we have here 22 crop and corresponding to one crop, we have only the 100 data set. 100 is not sufficient if it is about 1000 for one crop. Okay, and it will be when 20, for the 22 crop it will be 22,000. Okay, so this is the sufficient, and if you can have more than 22,000, this will be more accurate, more intelligent. So data is always play very important role. If you can choose only the 50 or 10, then this will not return. Sometimes this will not return the value also. Okay, and in the case of 100 values, many times when you will use this model, it may happen that there will be no output. It may happen. Okay, so if you have large data set in thousands, then this type of the model will have the more accurate values. Now in the cloud-based or social media, very huge data is there. Okay, that's why these websites like Amazon or YouTube, Facebook easily can recommend everything. Okay, we always in the routine share many information when we are visiting on the social site or the YouTube, Facebook, etc. And on the basis of this data set, and they are using for the companies. Actually, they are testing our, you can say the interest by actually we are sharing our interest on the website. They study sentiments. Okay, and on the basis of this sentiment, they are recommending the protection, and they are preparing in, just like which type of the interest the people have, and according to that, the companies are preparing the product. So this data is using for the companies. Okay, so here also we can easily develop establish our own model depend upon our data set, data size. Okay, so as much we have the large data set, we can make more intelligent. In the beginning, if you have a small data set, say 1,000 or 2,000, okay, but we can prepare our data model. So as soon as this will be used for the user, they will check it when when they will give some input, and according to input, when the user is satisfied, according to that, either he will like or dislike. Okay, thumbs up or down. Okay, so according to that, the machine will learn itself by the giving suggestions from the user. If the model is based on deep learning. Okay, so many things are there and many things we need to understand. We have to study. Only then we can do all these things. Any more? Any more question? The model and the content during these 13 days which we discuss is only the foundation. Okay, by doing all these things, you are not the expert now. You have to study many more things. Okay, but you can have the idea. Now you can do many things yourself. Okay, and study more, do some experiment, then you will realize the importance and how you can establish the today's model which I try to present here. I will share the file as well as script file and CSV file so that you can also check it, the steps, and the following same you can get some idea. Okay, and you can I will share with you some more data set without model. Okay, you should try how you can establish the model, and once you will able to understand, you should try. Okay, so I will try to share the some data set of the disease. So the same steps will be there. You will check, you can establish, you can run, and you can make intelligent model. Any more question, please? Okay. Dr. Abhishek Kumarji, Abhishek Garg, Dr. Javed Wasim, anyone please? I don't know the way of my lecture is fine or not, but if you can, Abudkar, can you please unmute your mic? Dr. Javed Wasim. Okay. Mustafa Grema. Is there any question, please? Otherwise, it is time to end our
No
session.
question for now.
No question. Okay. Mustafa Grema asked the question here. Okay, I think we have discussed everything for the today's session, and tomorrow is our last session, and also the validatory. I request to all the participants to share your views, your suggestion. Okay, and also you have to try to unmute, try to open your webcam when you will share your views, so that and also at the end we will capture the screenshot of the entire all the participants, so that during that time I request to all the participants please ready your webcam, so that when we will announce for the screenshot in the um, during the session. So if you will open your webcam, that will be fine. And also during the you share your views or your feedback, live feedback during the session. Also, I request you must open your webcam to present your view about this 2-week workshop. Okay, and your suggestions are very important. And during 13 days, I speak a lot and many things. You also ask your questions as much as possible. Okay, from your side also, and you keep your passion continuously 2 hours per day. So your experience, your inputs, your suggestion are really very valuable. So I invite you to all the participants to share your views by open your webcam and unmute your mic. Okay, this will be the live feedback and will help us to interact with us as well as your ideas. Actually, when we submit the feedback in Google form, I always study all these things. But when we talk or interact with each other, so we can also establish, you can say, collaboration. So this is, I think, when we interact on the live session, this is more effective. Okay, as compared to the submit feedback in the Google form, that is also important. Okay, but interaction is more important. So thank you very much for the today's session, and wait for the last session. And I always enjoy all the sessions with you, and I hope that you also try to get some information and enjoy all the sessions. And see you tomorrow at the same time. The session will start at 7:15, and during within very less time. Actually, mainly the discussion will be important, but I try to present one more model. Uh, okay, so thank you to all and good night. Stay connected and wait for the tomorrow. Thank you. Good night.